Hello everyone, my name is Rishi Kapoor and I am an independent product consultant for digital industry. Today I'm going to talk about machine learning or ML. The main goal of ML is to make decisions or predictions based on data. It's a powerful tool used in many fields, but let's see how it differs from similar areas like economics, psychology, and statistics. In economics and psychology, the focus is often on discovering why things happen, the underlying causes.
For example, psychologists might study why people behave in certain ways.
In statistics, the aim is to find models that describe the data well, like figuring out trends in a survey.
The end result in these fields is usually a model that explains the data.
In machine learning, however, while we do build models, the primary purpose is to use these models to make accurate predictions or decisions. It's like using a recipe, the model, not just to understand the ingredients, but to actually bake a cake, make a prediction or decision. As machine learning methods have improved, they've become the best choice for many applications because they're fast, efficient, and reliable. Examples include face detection, speech recognition, and many language processing tasks. Basically, if there's data or signals from the real world, to understand ML can probably do it. A key aspect of solving problems with machine learning is human engineering. Even with advanced algorithms, human input is essential.
Exactly. Human expertise shapes the way we define problems, choose algorithms, and interpret results. Without it, machine learning can't reach its full potential.
Here are the critical steps. First, frame the problem. Define what we're trying to solve. Second, acquire and organize data. Gather and prepare the data we'll use. Third, design solution space. Think of all possible solutions. Fourth, select a learning algorithm. Choose the method we'll use to learn from the data. Fifth, apply the algorithm, run the algorithm on the data. And finally, validate the solution. Check if the results are accurate and reliable. These steps are vital for the success of any machine learning project. Now, let's discuss the problem of induction. It raises the question, why do we believe that past data can help us predict the future? It's a philosophical issue, but in practice, we make some assumptions to make it work. For instance, we assume that our training data is independent and identically distributed, or IID, meaning that the data points are random samples from the same probability distribution. In machine learning, we typically need to solve two major problems. First, there's estimation. How do we make accurate predictions from data that might be noisy or inconsistent? For example, how do we deal with the fact that the same medical treatment might work differently for different patients? And then there's generalization. How can we make accurate predictions for new situations that we haven't encountered in our training data? To understand machine learning problems and their solutions, we can use 6 key characteristics. First, problem class. What type of data do we have and what questions are we trying to answer? Second, assumptions. What do we assume about the data source or the nature of the solution? Third, evaluation criteria. How will we measure success? What criteria will we use to evaluate the predictions or decisions? Fourth, model type. Will we create a model If so, what aspects of the data will it focus on, and how will it help us make predictions? Fifth, model class. What specific kind of model will we use, and how will we choose the best one? And finally, algorithm. What computational process will we use to fit the model to the data and make predictions? In summary, machine learning is all about using data to make smarter decisions and predictions. We rely on certain assumptions and frameworks to help us generalize from past data to future situations. As we continue, we'll explore these concepts in more detail and see how they apply to real-world problems. That's it for our introduction to machine learning. Remember, ML is a tool that helps us understand and make decisions based on data. We'll delve deeper into specific techniques and methods in our upcoming sessions. Any questions?
Can you explain how ML is used in real life?
Of course, think about voice assistants like Siri or Alexa. They use machine learning to understand your voice commands and provide the right responses. That's ML in action, making your life easier by understanding and processing your requests. Great questions. See you all next time in part 2 of this video, and keep thinking about how machine learning is shaping the world around us. Stay tuned for part 2 of the video series on basics of machine learning. See you all soon.